Okay, welcome everyone to this EA Post webinar. This is the last Friday of May in 2026, which we were saying earlier is kind of a strange time of year because most schools are on semester calendars. And if that describes you, your summer term has started or your summer break has started. But some schools are on quarters, and so it's sort of a long slog to get to early June if you're on quarters. Anyway, I'm rambling. I'll stop rambling. I'm Alan Rossman. I'm affiliated with Cal Poly, San Luis Obispo, and I thank you very much for giving up some of your time to be here today. I'm going to introduce Jill Vanderstoep. Jill's been working with the E8 Post project for many years and with various other projects related to introductory statistics and especially simulation-based inference for many years. And I learned recently that Jill's actually going to be retiring from this project and other professional endeavors very soon, probably in the next few weeks or month here. So I want to acknowledge Jill and thank her for all of her work. It's been a pleasure working with her for many years, and thank her and wish her well and let her introduce the person who will introduce our presenter today.
All right, great. Thanks, Alan. Can everybody hear me okay?
I can.
All right. We're going to do a double intro. I'm going to introduce Chatu, who I mentored back in fall of 2024 through the EA Post Scholars program. And she is currently in Memphis, Tennessee at Rhodes College. And she was very familiar with our simulation-based inference curriculum. And so I put her name forward as someone who would be a good mentor for someone else, kind of branching off from one and expanding into more. And so Chatu is actually a mentor for Michael this year. And so I will let Chatu introduce Michael.
Thank you, Jill. So, good afternoon, everyone. Nice to see you all today. So, as Jill said, I was a year post scholar in fall 2024 with Jill. So, that was a wonderful semester, and I worked with Jill about that paired sample data question with rinsing solutions, colored ones, or the uncolored one is going to work for the distance in runner. So, it was good, and I enjoyed a lot by doing that. And then I took a break with everything. And then again, in last year fall, I got an email from Alan. We are looking for 2026 spring scholars. And I just looked at what we have to do, and I couldn't find something matched with my spring classes and everything. But I just filled out that questionnaire blindfold, like whatever will work, I will do it, kind of like that way. I had time to do something. I really wanted to do something, but I couldn't find a match. So then Jill reached out to me like, what do you want to do? You already did one thing. I want to do the same thing. And I'm like, whatever you suggest, it's going to be fine with me. And then she, okay, like then I'll get you as a mentor and I can find you 2 to 3 mentees. So that's how I get to know about Michael. So Michael Nelson Horace is a PhD student in Stanford University, Department of Statistics. So he works with Monte Carlo theory and Markov chains. That's his main research area, and he does sociology applications too in terms of research wise. So right now he is successfully defended his PhD and ready to graduate in next month. So we are so happy for you, Michael. So after that, he will be going back to his country, Australia, as a research scientist in agriculture department in there. So everything worked out really nice. So I'm happy to have Michael explain what he did with the inference app, one proportion app in his class. His classes are challenging, really big. So you can hear about what he did, how he get through the challenge in his presentation. Michael, it's up to you.
Thank you, Chatu, for the introduction and for being a great mentor this program. So I will share some slides. Great. So I'm going to talk about the class that I've been co-teaching this quarter at Stanford and how I've incorporated some materials from EA Post, and in particular, adding more simulation-based inference for hypothesis testing. But I want to give a little bit more personal background first. And so I actually had the opportunity to attend a workshop at Cal Poly about a year ago where Alan and Beth and other professors at Cal Poly presented on some of the modules and materials used in EA Post and including some of the activities that I ended up incorporating in my class. And at that time, I was a teaching assistant for the intro statistics class at Stanford. And I, found the workshop at Cal Poly quite inspiring and thought that it would be great to incorporate some of that into our teaching here at Stanford. And then I was actually asked to co-teach the class. Essentially, the Professor Schramm, who was lecturing, she and her partner had a child over the summer, and so I was asked to help teach the class and reduce her teaching load during the academic year. And then after the workshop, I'd signed up to the EA Post discussion group and saw that there was this scholar opportunity. And since I was already thinking of incorporating some of the materials, I thought it'd be great to get a little bit more support. And I think it went really well. And so I want to give a little bit of background about the class. So this Stat 60 is also cross-listed with the psychology department, and it's an intro statistics class that's offered each quarter at Stanford. So Stanford has a quarter system, and some quarters it's taught by a psychology professor, but currently it's being taught in the stats department, and it varies a little bit across quarters depending on which department's teaching it. There's actually a course website which has more of the course materials and detail. But this is a sort of top line summary. There are 10 weeks with the quarter system, and there are around 150 enrolled students, which is a little bit higher than most quarters, but it typically has at least 100 students enrolled. And so there are 2 lectures, myself and Salil. And then we also have 5 statistics PhD students who are working as teaching assistants. And so they do the majority of the grading. They host a discussion section with the students and have and also help with some administrative work. And then each week there are 3 80-minute lectures, which all the students are invited to attend. I guess around 100 students come any given lecture. And then there are also these 50-minute sections where there's a single TA and then a smaller group of students. And these sections include a little bit of review, some practice problems, and then often an activity that's meant to give a bit more context to the material that they're learning about. And then each week, there's also a short in-class quiz on the Friday lecture at the end. And these quizzes end up being about half of their final grade. And then there's a final exam, which is taking place in just over a week. That is the rest of their grade. We no longer do any take-home homework because I think that a lot of them would use ChatGPT. And so we moved to more in-person learning. This is something that's kind of happening across the department and other classes as well. And Salil and I have been sort of alternating weeks. And so that's kind of worked best. We've made the class roughly have distinct topics for each week. And then we give all the lectures and make the section material and quizzes in each week and just sort of proofread each other's work. But we get to focus separately. And I think this has been working well. But I guess it does make maybe some students can find it a little tricky with us changing, but I think there's a fair bit of continuity across weeks. And so I next want to talk about the content we cover. And so Salil is actually inspired by this course / book from some professors at the University of Washington called Calling Bullshit or Calling Bull, where there's a lot of emphasis on kind of numerical literacy and being able to recognize things on the internet or in media as, maybe misrepresenting data, misrepresenting visualization. And so I think part of the course philosophy is to try and incorporate some examples from the real world of, showing people who misrepresent data and then show more positive examples of what people should do. And so we don't follow this University of Washington course closely, but some of the material comes from there. And I think it does inspire some of the teaching perspective. There's sort of 5 main topics. The first week is about putting numbers in context, and the kind of focus is just on numerical literacy. So if you see a number in a newspaper, maybe it just looks like a big number, but trying to contextualize it and compare it to other numbers and think about, is this number an average? Is it a total? Is it different from what I would have expected it to be? And then we talk about sort of data visualization and some data summaries and an exploratory data analysis topic that covers 2 weeks. Then we do some probability, and this is a mix of just sort of introductory probability and counting, and also doing simulation to compute probabilities. And then also some examples of people misusing probability or so incorrectly computing a probability, like maybe talking about the probability of A given B instead of B given A, and how sometimes in court settings, lawyers make this mistake when arguing about the probability that someone is guilty based on some probabilistic evidence. And then we have 3 weeks on inference, which sort of covers p-values, confidence intervals, and a little bit about experiments compared to observational studies. And so this is, sort of a big part of the class. And then at the end, we call it machine learning, but it's mostly, they learn a little bit of regression, and then tying in with the broader themes of the class, there's discussion about how just getting a bit of literacy in how people talk about machine learning and talking about the importance of data that is used in the machine learning model, and also how this textbook from the University of Washington authors have some examples where a company or some researchers promise some great machine learning algorithm, but when you look under the hood, you see it actually has lots of biases, and it's very dependent on the data it was trained on. And so there's not much theory, but sort of trying to give people a sense of, even if you don't understand what the algorithm is doing, if you know something about how the data was trained on, there are sort of potential issues you can find with these algorithms. So that's the broad course structure. What I want to talk about today is the sort of first inference week that we had in the class, which is when I used the most of the EA post materials and did this simulation-based inference to introduce hypothesis testing and statistical significance. I should have said this earlier. I'm happy to take questions now or at any point. So if people have any questions. Okay. Yeah, so my plan is to say, what did I do in this first week of teaching p-values and statistical significance? So in the first lecture, I used this chimpanzee solving problems example, which I saw at the Cal Poly workshop, and then also saw when I was working in Chattery that there were lots of information about other people who have used this example and presented in different ways. And so this is about a chimpanzee called Sarah who successfully solved 7 out of 8 problems. And so a little bit more specifically, this chimpanzee was shown videos of a human trying to complete a task, and then after the video was shown. Chimpanzee was shown 2 photos, one of which had the sort of correct solution to the task. Maybe it had a key and the person in the video had been struggling to open a box. And the other photo was something unrelated. And then Sarah picked one of these photos. And the researchers observed that Sarah successfully picked the correct photo 7 out of 8 times. And so I presented the results from the studies to the students, and then we talked about, what does it mean to get 7 out of 8 correct? What are some explanations for how well Sarah performed, and how could we assess those different explanations? And so the students were given coins, and we discussed how maybe if Sarah was just randomly guessing, then that could be modeled by flipping coins. And so each student would flip their coin 8 times and record the number of flips. And then this would give us something to compare Sarah's performance to. And so because it is this large class, and this is in a lecture with around 100 students, I had a Google form like this, which the students could access either on the course website or through a QR code that I had on my lecture slides. And then once they had flipped their coins, they would fill out this form and submit how many heads they got. And then the data from this form was being displayed in a sort of histogram or dot plot that would update as students submitted their answers. So at the start, there were no dots, and then each person, once this form was submitted, another dot would rise up. And then we discussed, okay, where would Sarah be in this distribution? How does that compare to the results of everyone flipping their coins? And one thing that in hindsight I realized I could have anticipated is that I think the students weren't flipping their coins very vigorously, which is something that I know Percy Diaconis, who's my advisor, has actually sort of studied how people flip coins, and that if people don't flip the coin with a bit of force, then it maybe only turns over once or twice. And so this histogram doesn't quite look like the binomial distribution it should in theory. There are like very many people who got all 8 heads or all 8 tails. And so this is something that didn't work so well, but we could still see that in general, most people weren't getting as many correct guesses as Sarah. But then what we did was we used this one proportion app, which I'll show you a bit later with another example, to actually compute the p-value of simulation and discuss how using an app like this can be equivalent to having a much larger class size where lots and lots of people are flipping their coins, and then we computed the p-value and sort of saw that it was small, and then we interpret that in terms of Sarah's original results. And so this first lecture was focused on this example and then introducing these ideas of hypothesis testing and p-values. And so after the activity, there were some more formal definitions and discussions of the activity. And then in the second lecture of the week, I wanted to follow up with another example, which is based on this Minecraft person named Dream. So Dream is someone who makes YouTube videos about Minecraft, and he is something called a speedrunner, which means that he's someone who tries to complete the game as quickly as possible. And in one of these attempts to complete the game, he was accused of cheating. And what happened was that one of the things you need to do in Minecraft is trade with some other character called a piglin. And so you give this character gold bars, and then you get back other items. And apparently the items you want are something called ender pearls. And in the standard version of the game, the probability of getting one of these pearls is around 5%. But in 262 trades, this YouTuber Dream received 42 pearls, which is sort of closer to 20%. And so far more than you'd expect under this actual probability of 0.047. And so we talked about this example, and then I opened the applet and asked them, how to use the applet in order to assess just how lucky this YouTuber dream got. And then the p-value you compute is really very small. It's pretty much zero. And so we sort of have very strong evidence that he was cheating. And I think this example is nice. It's kind of fun. I think the students find it funny when Salil and I talk about Minecraft, even though we don't really know much about it. And also, I think in this class, I introduced the idea of type 1 and type 2 errors. And I think this is a sort of concrete example for talking about type 1 and type 2 errors. Like here, the type 1 error would be accusing Dream of cheating when he's actually innocent. And the type 2 error would be letting Dream get away with cheating when he actually is. And I think this is a little bit more concrete than falsely rejecting a null hypothesis in a scientific study. And then we also just use this example to discuss multiple testing a little bit. This idea that there are actually lots of people who are playing Minecraft and trying to do a speed run. And so maybe we're being unfair to Dream. And so we talked about Minecraft. And so there's a question from Bryce. Exactly. The black lines are representing the distribution of how many pearls, how many of these successes would you get if you took 262 draws and had success rate 0.047. And so the expected numbers around 13, which is way, way less than the 42 from Dream. So yeah, that's right. And this graph was made using the one proportion applet, which I'll show soon, and you can enter that data of 262 draws and probability of success 0.047. Yeah, thanks for the question. And so yeah, so we also introduced a little bit about multiple testing and how this is potentially a problem in science and also potentially a problem in terms of trying to catch people cheating. And also, I think there's also a nice YouTube video about this example that goes into some more detail. And so I think actually this example could be fleshed out a little bit more using some of the ideas in this video where they actually sort of compute the probability and do some more examples. But for us, we just use the one proportion applet to to compute a p-value. Nice. And so then the next activity with the students was their discussion sections. This is the smaller group activity with the lecturer. And the idea here was that they would actually participate in an experiment, and they'll get their own data from that experiment, and then they'd be able to compute a p-value for their results, rather than the previous two examples of kind of taking an existing experiment or observation and then computing a p-value. And so the activity is based off this website called Which Face is Real, where if you go to this website, there are lots of pairs of pictures like the one I have on the slide, where you have to look at these two photos and decide which one is real and which one is artificial or AI. And so, Alan, I think I might need you to start the poll so we can all, or maybe I can launch it actually. Okay, great. So yeah, so the poll's been launched. And so, yeah, so just take some time to guess which of the two faces is real, or guess or decide. Yeah.
I'll give you another 5 seconds to respond, and then I'll end the poll.
Thanks.
Last chance. Okay, shall I show the results, Michael?
Yeah, sounds great. Okay, so most people think that the right face is real. It turns out actually the left face is real. So I think this is hard for a number of reasons. I think so. Yeah, one problem is that I guess there are just so many models for generating fake faces these days, and the website I think uses a slightly older model, and so like even if you have learned how to recognize these things in the wild, it's a little bit different depending on the model you use. But yeah, so in this case, the left face is real. Most people thought the right face was real. But yeah, so in the section, it was a little different. They were shown a few examples of which one was real or not, and then asked for a bunch of new ones, which one was real, and then shown the results for that, and then they could compute a p-value for each. And so the students were shown 8 faces, and then they used the one proportion app to compute their p-value. So I can show you what that would look like for our example just now. So this is the applet, which previously they'd seen me use in class, but now they were getting some practice. And so in the example we just did, there were 20 of us who filled out the poll. And if we were guessing, there'd be sort of a probability of 0.5. And so this one proportion applet flips coins on our behalf and will say what the results would look like. And so just here it's 10 heads and 10 tails, and you can do repeated samples like how in class many of them were flipping coins. Here 14 heads, 6 tails, and then we can get many repetitions all at once and get the sort of histogram of the results in class. And then we can compute the p-value by, I guess, entering it was 3 were correct and count. And so I guess 3 is over in the opposite tail than expected. So yeah, I think this is a hard task. Some students apparently did well, the TA said, but yeah, in general, I think it's hard to guess correctly. And yeah, so in the app, you can also do 2-sided tests. So that was something I talked about in class a little bit as well. And also options to, instead of the simulation, to use some analytical methods for calculating. But I focused on just the simulation for all of the calculations we did. So that was the discussion. Sorry, I don't know why. And yeah, they also had this practice quiz and some revision. And that's the structure of each discussion section. There's sort of an activity like this, revision, and solutions to a practice quiz. And then in the third lecture, it was when I talked about 1-sided and 2-sided test. And then the main thing was at the end, there's a quiz. And you don't have to, I put the text for the quiz here. You don't have to read it all, but essentially it's just describing a scenario in which there is a sort of hypothesis testing problem, and then they need to answer some questions about it. So this is about quality control at a battery factory, and in a sample of 100 batteries, 17 had a sort of short battery life, whereas the company target is 10% of batteries should have at most 10% of batteries should have the short battery life. And then they were asked to assess whether or not this is statistically significant. And so there are 3 things they were asked to do. The first is to describe the null and alternative hypotheses, both in English and with mathematical symbols. And then what I wanted them to think about was how would they do the sort of simulation to compute a p-value. And so it's just asking what are the things that they would enter into that applet, essentially. But then because they're writing with paper, I just told them what the p-value is, and then they had to interpret the null and alternative hypothesis and what does this say about the original study. And so they were given practice quizzes similar to this, where the only difference was what the text at the start was. It was, maybe something about a soccer player taking shots on goal and then comparing that to some other probability. And so this was the quiz in the last lecture of this week on hypothesis testing, where we really made the focus be on simulations to calculate p-values instead of equations and analytic methods. And I want to give some conclusions about how this went. And so I think using coins went really well, even though the histogram didn't look great. I still think it is valuable to do the tactile simulation. And also and I think it just makes it a bit easier for students to connect this idea of a p-value or hypothesis test is asking the question of what would the study results have looked like under the null hypothesis if this chimpanzee or the students, when they were looking at the faces, was just flipping coins or had some other known probability of success. And so I think there's good pedagogical reasons to do the actual coin flipping. And I think also it helped to focus on single proportions. So to have just different examples where the hypothesis was about whether or not a sort of yes/no question of some binary variable had a given probability of success, and then to show different examples of that. I think having that sort of narrow scope made it easier to focus on the conceptual things of what a p-value is, what the null and alternative hypotheses mean and are. But there were still a few sticking points for the students. I think I'm still not sure of the best way to explain one versus two-sided tests. And I think it maybe would have been good if I had a two-sided example earlier than I did, and this might have helped. And I think in particular, they were a bit stressed about the quiz and whether or not that should be one or two-sided. And so I told them they could do either and they wouldn't be penalized if they did. But I think they were still quite stressed. And then the sort of transition from hypothesis testing to estimation, I think, is also something that we'll try to work on in this class. I think, it was very nice that the testing was focused on single proportions, but then when it came time to estimation, there was more discussion of quantitative variables. And I think we could make that smoother in terms of the connections between testing and estimation and binary variables versus quantitative variables. And as we are a quarter system, I don't yet have very detailed feedback. So the students will give end of quarter evaluations in a few weeks, and then I might hear a little bit more about how these activities went. But from the TAs who interact with the students on a more personal level, and I think perhaps get more direct feedback, they said in the team meeting we had at the end of this week that in general they seemed less confused about p-values compared to other iterations of the course. And I think that's because partly because we introduced this sort of simulation perspective, and then also partially because we were focusing on sort of these simpler examples of single proportions and then letting them focus on the conceptual things about what a p-value is. So I was very happy hear this. I did also compare the quiz grades, and they did better on this quiz, but I think this isn't quite a fair comparison because last year when the class was being taught, they had to do some computation for their p-value, and that's where most of them lost marks. And so, yeah, it's not exactly a one-to-one comparison, but I do think, yeah, hopefully conceptually they understood what a p-value was a bit better because we were moving away from the computations. And that's all I have. So thank you for your time.
Thank you very much, Michael. How about some questions for Michael? Feel free to unmute and ask or type in a chat, whatever is more convenient for you. I'll start with one while others are getting their question ready. About the quiz you gave, it seems that there were a lot of words to be read. You asked them to describe the simulation process, so they must have had to write a few sentences for that. And also describing their conclusion about the null hypothesis involved some reading. And there were 150 students. So was it the TAs who were reading these and grading them, or how were they graded?
Yeah. So yeah, the TAs have graded the quizzes, and I guess they're 10 weeks, so 10 quizzes, and what the TAs asked is to have 1 week, also to grade an entire quiz. And so they have each TA has 2 weeks when they have to do this large amount of grading. So yeah, so it's definitely a lot of help to have the TAs. But they haven't complained too much. So they're good.
And it was just one TA grading all 150 for this quiz. So hopefully there was consistency there.
Yeah, exactly. So yeah, so one TA grades all the quizzes. We use GradeScope. So GradeScope has nice features where you can, if you upload a blank quiz and you can make a template where you indicate where the student's name will be written, where their student IDs will be written, and then it can automatically assign scanned PDFs to students, and it does this quite accurately. And I think that has helped with the administration, and I believe the TAs maybe also prefer it for grading, especially in cases where the students are getting the right answer most of the time, then they don't need to give much feedback, and GradeScope is quick. One downside of GradeScope is it's a bit harder to give comments for students who maybe didn't fully understand the question. But yeah.
Thank you. How about another question for Michael? And Nishan, go ahead.
Hi, thanks. So, hi, Michael. Thanks. It's a very great presentation. Thanks for sharing your experiences. So, I also teach rather large classes, and I was wondering if you could talk a little bit about maybe how often you were able to do these active learning type exercises. Was it in every single lecture, or how frequent they were? Were they in lecture or as well as tutorial? And how you were able to manage the time with teaching this, plus also having these activities which are useful with conveying the learning, but also having enough time to cover the syllabus?
Yeah, that's a great question. I guess it was maybe sort of one activity a week, roughly. Or yeah, yeah. Yeah, I think it's hard. They're not. It is hard to translate to the large classroom setting. I guess for this week, the main thing was like when they actually flipped the coins was just for this first study with the chimpanzee, and then later it was more I would explain what I was doing and then ask questions from the class, but not necessarily ask them to do the computation on their own or in a small group. And yeah, so that was yeah, it is tricky with the large classes, and yeah, no, yeah, maybe one lecture a week has a activity that takes up a fair chunk of the lecture, but then otherwise it's more of a standard lecture.
Thank you.
Another question for Michael, or comment, or anything you'd like to say? Laura, go ahead, please.
Hi, Michael. Thank you for the Minecraft example. My son loves Minecraft, so I can't wait to show him. I had a question about, we've done an AI activity, like can people detect AI in our classes? And one of the students was saying that, and it made me think of it because of the pictures that you chose, the pictures that they chose, that how many of us actually picked like the wrong one. And they had said something like, well, if it's trying to trick you, and they didn't like really agree that it would be 50-50, which I thought was an interesting point. And I didn't know if like that came up in your class, or if you knew how the quiz was constructed. Like, was the quiz trying to prove a point, or were they like the pictures randomly paired together? I don't know. It was just something that I thought of because your example made me think of what the students had said in my class.
Yeah, that's a great question. I think so where exactly is the randomness coming from in this example, if the null hypothesis is true? So yes, I think this website just has some data set which was used to perhaps train a particular model from a little while ago, and then has kind of the training images of actual people and then what the model produced. And I think it is selecting those images and then putting one on the left and one on the right. And so I don't know if it's necessarily trying to trick people. And actually the website is quite nice. It has, many examples like this. But then if you go to, I think, actually, maybe this is how they explain how they have a learn section. So tips for how you can tell, but I think this is already out of date. Is the problem is that, they use some model published a little while ago. And so I think, although maybe you can learn how to tell these faces, they're quite different from maybe the faces that you would see in the wild today. And so I think there is probably a good activity that like is maybe some combination of what you did in class, what these people have on their website. But yeah, it is a tricky one to like stay up to date, I think. Yeah. Thanks.
There's a question from Bryce in the chat. Have you compared students' understanding of simulations when they're watching your simulation versus their own with coins? In other words, do students understand simulation as well if they watch a coin flipper versus being the coin flipper?
Yeah, that's a really good question. I haven't done that comparison, and I'm not sure of the exact results, and it would be maybe interesting to compare to say Cal Poly where maybe there's a lot more hands-on simulation done by the students. I think one thing that might have been better would be maybe if I got them to use the applet instead of me showing them the applet all the time. Maybe if they got more practice using the applet, they could have understood a bit more, because I guess I would open the applet and then ask the class what I should do, and someone would answer, and maybe that student knew what was going on. But I think maybe the advantage of getting everyone to do it is that everyone has to do it. And then it's not just the strong students who are answering the questions. Yeah.
Thank you. Another question in the chat, this one from Anna. Have you used other web-based tools such as StatKey?
I haven't used StatKey. So I've used this the applet, the Rossman Chance, and there are a few other applets I've looked at. I know Dennis Sun at Stanford has also made some similar box model type applets. And yeah, I think using the applet in class is probably something that could have been done better, is to say, talk them through it and then let them do it on their own. I think it's, but I don't know what StatKey is. I'll look into it.
Other questions for Michael?
Michael, I have a question. Sorry.
Go ahead.
Can Yeah. So you mentioned that you alternated with two instructors. So when you introduce this method, did the other instructor use a similar method, or he used the same method or different method?
So we did do the similar method. So yeah, so we alternated weeks. And so what I sort of talked about now was, roughly 1 week of material, which was the first week of hypothesis testing. Then when Salil taught the next week, she talked about kind of observational studies versus experiments and correlation. And then she talks about, how you could do a permutation test for association. And so then that also was based on simulations. And so so she did similar things, but with different examples. Yeah.
And I wonder how difficult it was to synchronize between two of you.
Yeah, I think it has been going okay. I think it's definitely not perfect. But I think the one alternating weeks has worked surprisingly well. I think perhaps because we are alternating, the material seems to chunk fairly well into like week-sized topics. And so then, hopefully there's enough continuity, but also enough difference between weeks. But yeah, maybe in the student feedback, we'll see if the students find it hard. But so far, I think we've managed to be fairly cohesive.
Okay.
Yeah.
Thank you.
I see a question under Q&A. Let me read it to you in case you don't have access at the moment. How did you go about introducing the choice for the null and alternative hypotheses? For example, in the dream cheating problem.
Yeah. So I think for the thing that worked well, I think, was the students were able to sort of see what the null hypothesis should be in terms of the probability of success under the null. Is in Dream, I told them that, in the game's code somewhere, it is this, 0.0047, 0.047. And so then they were able to see that. I think in other examples, it was sort of like there are 3 possibilities. And so if you're picking randomly, it's 1/3. So I think that was something students were good at. But as I said, the sort of one-sided versus two-sided, they were confused about. And partly this is because I mostly did one-sided examples to begin with. And then also, I think the sort of p-value calculation is a bit more complicated with a two-sided hypothesis when you have to look at both what was more extreme to the right and more extreme to the left. So yeah, that was something they struggled with. A little bit more was going from, okay, this is the null proportion, but then also should it be one or two-sided was harder.
I have a comment to follow up. It's really interesting, the data you collected on us. I mean, for the one-sided test, the p-value was essentially 1. So there's no evidence that we do better than guessing at deciding which was real and which was AI. But for the two-sided test, the p-value is virtually 0. So there's very strong evidence that we're different than flipping a coin when it comes to deciding which is real and which is AI.
That's true. But yeah, I think this maybe relates back to Laura's question of, did I pick a bad example that's somehow tricking everyone or something like this? And what exactly is the null? But yeah, it is. I wasn't expecting that, but yeah.
Sorry about that.
No, I actually like the example because
Sure.
it displays or provides evidence that we don't have agreement.
Yeah.
We disagree.
I also think if that happened to me on an example in class, it's an opportunity to make the point that sometimes you don't need to conduct the hypothesis test. Of course, if only 3 out of 20 of us got this right, quote unquote, there's no evidence that more than half of people in general would get it right.
Yeah, yeah.
In other words, I think students who just learn the algorithm fail to use their common sense sometimes, and they would plug in and do the calculations when it's clear if the sample result is not in the direction conjectured. There's no need to do the calculations. There's certainly no evidence to support the research hypothesis there. Thanks for all the questions. I think we have time for one or two more if anyone would like to offer one.
Hi, I just had one question regarding the possibility of if your students would benefit from like exploring how to use Microsoft Excel or spreadsheets, if that's at all a consideration in your class as to with a view towards when they do get out that they would be using that kind of a thing. Do you have any part or opinion about how that might be of value to your students?
That's a good question. I think it would be useful. What we tried in a different discussion section was getting them to use using AI to generate data visualizations. This is something that Salil wanted to teach them, and so we did sort of talk about that and how this is maybe something that they could do in general. But yeah, but I think also the spreadsheets is maybe something much more concrete and also a very useful skill to have. But we don't emphasize, yeah, we don't teach that, but I think it could be good to let them actually see data in the form of a spreadsheet.
And clearly, with the way that the simulations are set up already, then really engaging them conceptually first instead of saying, well, here's a spreadsheet command. I think that it's the right approach. I really do.
Yeah, I think that there are ways to make that translation, and I agree.
Yeah, I think I'll stop the questions there, but thank you very much, everyone, for being here and for engaging with so many great questions. Thank you, of course, to Michael for spending his time with us and giving us some wisdom based on his experience. Best wishes to Michael in finishing your degree and your move back to Australia. And I'll stop the recording and we'll end it there. Thanks for being here, everyone. Have a great summer.